All right, today we're talking about solving quadratics, and in class we started with a warm-up. The first equation was this. So we had 2x squared minus 3 equals 5, and our goal was to solve this in the most efficient manner. And we saw that because we only have that x squared term, we don't have an x term as well. This doesn't say 2x squared like plus 3x minus 3. Therefore, we can solve by taking square roots. So we ended up solving this by taking square roots in 4 quick steps. The answer was plus or minus 2. Now for number 2, for this one we could not solve by taking square roots because we had an x squared term and also an x term. So we had to solve by factoring here. So once we put it in standard form, we factored it and then did the zero factor property and solved the 2 different values. Number 3, this also can only be solved by factoring, but it's not factorable. There's no 2 numbers that multiply to get 53, but add to get negative 18. So the question today was, does that mean that there's no solution? Well, the answer is not necessarily. There's got to be some other way we can go about solving this quadratic that lets us see what the answers are. And so the method that we learned today is called completing the square. And we can solve quadratics by completing the square, and the great thing about completing the square is it always works. So let me show you how we can solve that problem that's not factorable by completing the square. Well, what we can do is we can subtract 53 from both sides. So we have negative 53 on the right, and we'll just bring down the x squared and the negative 18x. Now, I can add a value here that's going to make me able to factor the left-hand side. So I'm going to add 81 to both sides. So the question is, why did I add an 81 here? Well, I think you'll see once we factor the left-hand side. The 2 numbers that multiply to get 81 and add to get negative 18 are negative 9 and negative 9. So this factors to x minus 9 times x minus 9. Negative 53 plus 81 is 28. And we can rewrite x minus 9 times x minus 9 as x minus 9 squared. And so now, hopefully you see that we can solve this equation by taking square roots. If I take the square root of both sides, I get x minus 9 equals plus or minus, square root of 28 is 2 root 7. And if I add 9, I get x equals 9 plus or minus 2 root 7. So those are my 2 answers, 9 plus 2 root 7 and 9 minus 2 root 7. If you put these into your calculator, you can see what they are in their decimal form. So while this equation was not factorable, notice that we can solve it by completing the square. Just making sure we're still rolling. Okay, let's look at another example. Number 2. Okay, so for this one, 4m squared equals 21 minus 8m. We want to go ahead and put this in standard form. So that's 4m squared plus 8m minus 21 equals 0. And notice now we have a leading coefficient other than 1. To complete the square, we cannot have a leading coefficient other than 1. So how do I get rid of that 4? What we can do is divide both sides by 4. So now I have m squared plus 2m minus 21 fourths equals 0. The leading coefficient is now 1. We're ready to now go through the process of completing the square. First, we add the constant term to both sides in order to make space for completing the square. Now the question is, what goes here? Well, let's look back to the last example and think about why we added this 81. Well, by adding that 81, we were able to factor the left-hand side such that the 2 factors were the same, x minus 9 and x minus 9. If you can see that 81 does that, great. If you're having problems seeing how I got that 81, there's a couple steps we can take to get it. So what we do is we look at this term, its coefficient. So negative 18, what we do is we take negative 18, divide it by 2, and then square. So negative 18 divided by 2 is negative 9, and negative 9 squared is this 81. So that's how we complete the square. We take the coefficient of the second term, we take that b value, divide it by 2, and square. That's what we add to both sides. So over here, let's think about how we get this missing value. Well, we take this value 2, divide it by 2, and square. Well, what's 2 divided by 2? 1. What's 1 squared? 1. So I add 1. Whatever I do to one side, I do to the other. Don't forget that. Now, we can factor the left-hand side. What two numbers multiply to get 1, but add to get 2? 1 and 1. So that means we could write this as m times 1 squared equals 25/4. And now we just solve by taking square roots. So that's m plus 1 equals plus or minus. The square root of 25/4 is 5 over 2. So m equals negative 1 plus or minus 5 over 2. So m equals negative 1 plus 5 over 2. I'd have to make a common denominator. Negative 1 would be 2 over 2. So that's 3 over 2. And negative 1 minus 5 over 2 is negative 7 over 2. So those are the two answers. Let's see if you can do these two. Maybe pause the video and try number 4 and then play it to see if you got the same answer. All right, let's see if you got it right. To complete the square, we notice that the leading coefficient is 1, so that's good. We can now make room by adding 25 to both sides. Now I need to figure out what value do I add to complete the square. I take the b value, divide it by 2, and square. So that's 16. So this factors to a minus 4 times a minus 4, which can be written as a minus 4 squared. Then I take the square root of both sides, add 4. So the two answers are a equals 4 plus 7, or a equals 4 minus 7. Now try number 5. Make room. Add the b value divided by 2 is 3, squared is 9. The two numbers that multiply to get 9 but add to get 6 are 3 and 3. So that's v plus 3 times v plus 3, which can be written as v plus 3 squared. Take the square root of both sides. Always remember we have to write plus or minus. Subtract 3. And so those are our two answers. Negative 3 plus square root of 19, negative 3 minus square root of 19. All right, so that's what we did today in class, solving quadratics by completing the square. The great thing about completing the square is it always works, whether the answer could be factorable or not.